Hey everyone, let's dive into the world of ratios. Ratios are like secret codes that unlock relationships between numbers. Imagine you have 12 apples and your friend has 6. The ratio is 12 to 6 or 2 to 1. Ratios help us compare quantities and see relationships. When writing ratios, it's important to be organized and accurate. The order in which you write the numbers matters a lot. Let's say we're comparing the number of cats to dogs in a pet store. If there are 5 cats and 10 dogs, the ratio of cats to dogs is written as 5 to 10, not 10 to 5. See how the order makes a difference? Just like we simplify fractions, we can also simplify ratios. To simplify a ratio, find the greatest common factor, GCF, of both numbers and divide each side by it. In our pet store example, the GCF of 5 and 10 is 5. Dividing both sides by 5, we get the simplified ratio of 1 to 2. This means that for every 1 cat in the store, there are 2 dogs. Remember, when simplifying ratios, we only use whole numbers. We don't want any decimals or fractions hanging around. Keeping our ratios in whole numbers makes them easier to understand and compare. It's like keeping our math neat and tidy. So, when writing and simplifying ratios, remember to pay attention to the order of the numbers and always simplify to the smallest whole number ratio. By following these simple steps, you'll be a ratio master in no time. Negative numbers can sometimes pop up in ratios, and it's essential to handle them correctly. The negative sign always stays attached to its corresponding quantity. For example, if we're comparing the number of students who passed a test, which is -3, to the number of students who didn't pass, which is 7, the ratio would be written as -3 to 7. We don't simplify ratios with negative signs in the same way we simplify ratios with positive numbers. We can't just divide both sides by -1 to get rid of the negative sign. The negative sign is an important part of the ratio and tells us something about the relationship between the quantities. Think of it this way, the negative sign indicates a decrease or a loss, while a positive sign indicates an increase or a gain. In our test example, the negative sign shows that fewer students passed the test compared to those who didn't. So when dealing with negative signs and ratios, remember to keep the negative sign attached to its corresponding quantity and don't try to simplify it away. The negative sign is our friend and gives us valuable information about the relationship between the numbers. Section 4. Exploring rates, comparing different units. Now let's move on to rates, which are like supercharged ratios. Rates compare quantities with different units, unlike ratios, which compare quantities with the same units. For instance, if a car travels 120 miles in 2 hours, the rate is 120 miles per 2 hours, or 60 miles per hour. We use rates all the time in our daily lives, from calculating the speed of a car to figuring out the price per ounce of our favorite snacks. Rates help us compare things that wouldn't normally be comparable. For example, we can't directly compare the distance a car travels to the time it takes without using a rate. When writing rates, we usually express them as a quantity of 1 unit per 1 unit of another. This makes it easier to understand and compare different rates. For example, instead of saying a car travels 60 miles per 2 hours, we simplify it to 30 miles per hour. Understanding rates is essential in many areas of math and science. They help us make sense of the world around us and solve real-world problems. So, embrace the power of rates and unlock a whole new level of mathematical understanding. Section 5. Ratios and rates in action, real-world applications. Ratios and rates are everywhere in our daily lives. Let's look at some real-world examples to see how we use them. Baking. When baking a cake, we use ratios to combine the right proportions of ingredients. For example, a simple cake recipe might call for a 1 to 2 to 3 ratio of butter, sugar, and flour. Shopping. We often use unit rates to compare prices at the grocery store. For instance, if one brand of cereal costs $4.99 for a 16-ounce box, and another brand costs $3.49 for a 10-ounce box, we can calculate the unit price per ounce to determine the better value. Sports. In sports, we use ratios and rates to track performance. For example, in baseball, we use batting averages, hits per at-bats, and earned run averages, runs allowed per 9 innings, to evaluate players. Travel. When planning a road trip, we use rates like miles per gallon, MPG, to estimate fuel efficiency, and kilometers per hour, kmh, to calculate travel time. These are just a few examples of how ratios and rates play a vital role in our everyday lives. By understanding these concepts, we can make informed decisions, solve problems, and better understand the world around us.